So, hopefully I'm live. Let's just see. Okay. So, today we'll be coding Conway's Game of Life. But before that, let me just see if I'm streaming. Okay. Hopefully I am live. Yep. Seems to be the case. Okay. Let's just start. I'm going to be coding Conway's Game of Life in Golang. So yeah, and this is my first stream. Hopefully it's not that messed up. Go mode init. Okay. Touch. Make file. Okay. Make file. We'll create an exec. So go build. Output as target exe from main.go, and then we run rexe, and then clean because why not? Target. Okay, so that is done, and now we can create a main.go file. Main.co. So package main, and let's just print hello world for now to see if the setup is done right. Print hello. Let's go with stream because for stream why not? And if I do make exe, okay, setup is right. So Conway's Game of Life. So from my understanding, Conway's Game of Life has few set of basic rules to show or to showcase patterns that you can't easily code. So you just follow a few rules and let the code run, and the code just develops a pattern. And these are the 4 rules that is used in Conway's Game of Life, right? So if I'm just going to paste it here, rules, and yeah, let's just format it. So my idea for doing this is basically have an array of arrays which store integer values, zeros and ones, and we basically hold a state using a 2-dimensional integer array, and when we want to print it to the terminal, this is going to be emulated in the terminal directly, just fancy clear screen and then print string. So we'll use the 2-dimensional array to build a string. So that's basically the plan. So let's just map it out over here, what the plan is. So the state is held using a 2-dimensional integer array, and this is passed into a converter, So it takes int and returns me a string, and then we clear the terminal and print the string. So that's the basic idea of what I'm trying to do over here. So let's get started with updation of state. Since we have the rules, this is going to be used to update state, right? And we take a state parameter that is int. I think we could do uint, but for now let's just go with int. And we return a two-dimensional array. So we try to optimize it a bit late, not try to optimize, like try to fiddle around with it once I'm done with the main code. So for now we'll just try to get it running. So updated state will be a two-dimensional array of integers. So of len of state, and for I in range of state, we just do updated state of I is equal to make of len of state of I. Or we can just go with row over here and row over here. This should be good. Now we have an updated state that has only 0 values. Now we have to traverse through the state again to apply the following rules. So a range of state is for j comma val in range of row. So now we have to figure out the neighbors. So if we take an example, like let's say xx oxx and yank and ppp. So this specific O has 8 neighbors, one up, one down, one right, one left, and all the immediate diagonal positions, right? So now we have to get a count of neighbors that are ones, because 0 means there is no cell and 1 means there is a cell present. So we have to figure out the count of cells present around one specific cell or one specific position. So that's where we get count is equal to get count, and we pass in state, and then we pass in I comma j. Right? I don't think we need val over here, so we should be fine with this. And now we have to code the get count function that is taking in a state value, and then the two positions, and we return an int. So first we'll initialize count to 0, and then after that we have positions it needs to check. I can manually encode it or manually code that, but I think it's better to just create another two-dimensional integer array that has all the positions it needs to check. And yup, this is 2 on the same level and 3 in the bottom level. So, okay, the top's x value will be 1, middle value will be 0, and top's left value will be -1, and then middle value is 0, and the rightmost value will be 1, and same thing for the horizontal y value. The top will be 1, middle will be 0, and -1. So if you go with that, this is -1, 1, and then 0, 1, and 1, 1. If you go over here, it's -1, 0, and no 0, 0 because that's the position. That's I comma j, and then 1 comma 0, and -1 comma -1, -1 comma 0, and oh, I think I messed up. Okay, I needed to be, oh, this -1 itself, okay. -1 comma 1, what did I do over here? 1 comma 0, comma 1, okay. And this should be, yep, I did mess this up. -1, 1, 1, 1, 0, -1, and 0, 1. Okay, so this seems to be right. These are the positions we'll be checking. So for dir, okay, it'll be this dir in range dirs. Basically, we need to get x and y position, x and y coordinates. And over here, I wanted to overflow. So I need to create x and y in such a way they can rotate. So I could add the the max dimension and sum up the actual position. So even if it's negative, it will still be positive and take a modulus of the max position. So what I'm basically saying is if the dimension is n cross n, right? That means I could do something like I minus dir of 0 to get a positive value, and if I wanted to conform to n, I could just do modulus n. And same thing for the y value. So this would basically do the trick. I should be able to rotate and check. You could try this. So if there is any issues, we'll get to see that during runtime, I suppose. So but I'm pretty sure this should work. dir of 0 mod n. Okay, n should, we had to set m and n value. J minus dir of, I'm sorry, this should be 1, but yeah. Okay, so now I had to get m and n. N is len of state, and M is len of state of 0. So with that we have this. Now we have to get if state of x and y equal to 1, count plus plus, and if it's not, we should be fine, right? And then we return count. So this is to get count and get count after we get count. Now, what are the if conditions? If count is less than 2, so fewer than 2 neighbors, underpopulate. So updated state of I comma j is 0. As if 2 or 3 neighbors live in the next generation, and if it is more, if cells with more than 3 neighbors dies, and cells with exactly 3 live. So I could just do this. So they say 2 or 3 next generation. That is if as count is less than 4, they say updated state is of I comma j is the same as state of I comma j, but in the second they say exactly 3. So that basically means if count is 2, they live on. As if count is equal to 1, I mean 3, updated state of I j state, oh, it becomes 1, and else they die of overpopulation. So updated state of ij is equal to 0, and this is basically it. I think this should be fine. And yeah, let's get the state converter. So let's call it a state converter, I suppose. State converter. It takes in a state that is int and returns a string. So output is an empty string for now. Now we go through all the values. So for row in range of state, for val in range of row, if val equal 1, output equal to. So let's see. I was looking around to which symbol to use. So the output is this. We'll go with this. And else we'll go with, I suppose we can go with this. Both seem to be the same size. Okay. And once we come out of the inner for loop, we had to concatenate a new line for it. Hopefully this should do it. This should be the converter for us. Now comes interesting part. Now we have to build the state. Initial state is going to be make and then we should pass in a length. Yeah, let's go with 15 for now. And for I in range of state, we had to initialize the inner one. So state of I make and let's say 25, a rectangular one. Okay. Now we have to come up with the current state. So 3. Let's see if there's any pattern we can just take that is not complicated. So we could, is there any way? So is there any generators? For now, let's just take a simple one. Okay. Yep, this one. So it's 3 and 1 and to the side. So it is x yank 3 and 1 and to the side. So seems like we'll go for this one. So if we go state of 8 and 25 is this, so let's take 12 is 1, then we yank PPP R9 10 11, so that's 4 11 and 11 yank and 10. Would this be this? Or we could just print it out and see actually. So now we can, actually this gives us an opportunity to test out a converter, state converter pass state, make exe. Oh, net, okay, we imported net that time by accident. Yep, seems to be working, but this seems to be too cramped. Let's just try putting some space. Okay, yep, this seems perfect actually. Okay, now that we got our current state, now this is our current state, we need an infinite loop. For we get a new state that is from update state, and before that yank p I k. I want to clear the screen first, so we can run os dot command delivery. Or is it exe dot command clear dot std out is os dot std out clear dot run. Hopefully this works. Okay, it works. And need some sleep. Time sleep. Let's just put 100 milliseconds. And okay, new state. Ah, why did I do that? We could just do this. Since did I do 4? Okay, I can remove this one. Yep, seems to be working. Okay, that's awesome. Now, and just give a rundown on what we could change. I would like to pass in pointers over here instead of the actual thing, but yeah, the moment I do this, seems like there's a lot more issues that come up. I hope Pro just works. Uh, let's see if this works. Now we did get it running, so now all it is fiddling around and trying to see where I can just tweak it a bit to get it running better. Okay. Where is update state? %. Okay, that works. Let's do that for every state we did. Okay, this and this. Okay, and everywhere else I need to pass in %. Okay, get count. Where's the calling get count? That was in update state. Oh, I can just pass it as state. Yeah. Okay, that seems to be working. And what about the logic? So I did think about a small optimization. I don't know if it's an optimization, but it reduces an if condition. We're just saying if it's equal to 1, and then we, what do you say, add increment counter by 1. So what I was thinking was, since the state value if a cell is present is 1, we could just get away with J and remove the if condition. This should essentially work because the only other value is, oh, it was X. Yeah, I was wondering why. What did I do? Okay, X and Y. And yeah, this should, yeah, reduce one if condition, I suppose. One if check. And is there anything we can do over here? So if it's 2, less than 2, it dies. More than 3, it dies. And 2, it stays. and this stays. We could just remove this. I'm not sure if this will work, but we could try. If it works, I can give a small rundown on what I thought. Okay, seems to be working. So what I did over there was basically, if you see, we are initializing this to 0, but the new updated state we create, all the values by default will have the value of 0. So I just removed the conditions where we are initializing it to 0, because why check it? Because the value is always going to be 0. So yeah, and that seems to be working. So that's cool. Okay, and is there anything more? We could delete this. Everything else seems to be working fine. We could try another set of Shift O. Let's just off this by 5. Off this by 5, as in then there should be 4, there should be 5, 5, 5. Oh, I mean, that should be 6 and 6. Okay, let's try something more. So this is also having the same pattern. Is there any chaotic pattern we can just try? I don't know. Let's try some random pattern. So this would be yank n13 r3. Let's see what one does. Okay, it clears it. Now what we want? Rx. So yank and r13. Oh, r13 to yank and p. Rx. So I need to remove this, and I have to create R0 and 7 and R1. Oh, that's an interesting pattern. Let's see if this hits one of them and see. Oh, okay. Fair enough. And what if I reduce? Okay. One run. Let's just go full and just see this. Okay. And once that touches it, it should. Yup. So this is Conway's Game of Life. I think that's all I have for the first stream. Conway's Game of Life. And thank you.